so 6.6 is solving radical equations, and you can see one of our goals is also to identify extraneous solutions. So extraneous solutions are going to occur when your domain is not all real numbers. So we're going to talk about what type of situation we're going to encounter today. And with your radical equations, it's important that we understand the inverse of operations. So when you are undoing an operation, you always use the inverse. Like multiplication and division are inverses, addition and subtraction are inverses, and the inverse operation of a root is a root. How would you undo a root? Yeah, square it if it's a, oops, sorry, you said square, so I wanted to write 2. I'm just going to write x in here. Okay, so the inverse operation of a root is going to be a power. Okay, and so, yeah, if you have a square root, like you guys said, we're going to raise each side to the second power. Okay, and this is a key step to solving, so that's absolutely something I'm going to be looking for in your work, is that you're showing what you're doing to both sides. Okay, and then if you have a cube root, you're going to raise each side to the third power. Fourth root, fourth power. Fifth root, fifth power, so on and so forth. So when you have those, you might have something like the fourth root of x. Okay, when you raise each side to the fourth power, you'd be left with the radicand. Okay, and other times you might have
the interruption of sometimes things relationship boys and girls both like
okay, and then we're going to raise each side. Maybe you have a binomial, that's fine too. You're still going to raise each side to the fifth power. And when you do that, you're always going to be left with the radicand there. Okay, so I said now let's think about powers. We know the inverse operation would be a what? It would be a root, right? Because they're inverses of each other. Okay, and then if you had a quantity raised to the power of 2, that means you would have to take the, it's the power of 2, it's the, that's what you guys said, right? In general, it's a root or a radical. Okay, and then for the power of 3, we would have to use the cube root. Okay, so on and so forth. Now let's think about if the power was a fraction. So we're going to look at the examples below. You have x to the 1/2 equals 3. Okay, if you have x to the 1/2 power, that's the same thing as saying what? It's the same thing as saying the square root, right? So x to the 1/2 is the same thing as the square root of x equals 3. Right? And we just talked about if you have the square root, you're going to raise each side to the second power. So in this case, your x value would be 9. All right, so based on that, I want you to do number 2. And you can also start thinking about number 3. But for number 3, I forgot to fix this on your sheet. So will you change that to a positive 2 for me? If not, it would be an imaginary number, and I'm not going to worry about that, okay? Okay, so remember, one of the things I'm looking for is that you are showing that step of what you're raising it to. So if you have x to the 1/5, it's the same thing as the fifth root. So on each side, what would we be doing? How do we undo a fifth root? The fifth power. Okay, good. So when you do that, you can also think of it like this. What's 1/5 times 5? 1, right? So this is just x to the first equals 2 to the 5th, which is going to be 32. relationship between 1/5 and 5? What's the relationship between 1/5 and 5? You can say they're what? Yeah, reciprocals, good. Okay, so if you raise it to the power of the reciprocal, it's going to make it 1. So if you have x to the 2/3, you can raise each side to its reciprocal. So this is what you have. Change that to a positive 2 for me. And if you raise it to the power of 3/2, then 2/3 times 3/2 is 1. So you just have x to the first. And now we can use our rules, our power rules, right? If it's on top, it's the power. If it's in the denominator, it's the root. Okay, so this would be the square root of 2 to the 3rd, which is the square root of 8. And what's the perfect square in 8? 2, or 2 comes out, but it's 4. 4 times 2. Yeah, yep. And so with this one, it will just be your 2 root. All right, so when you're undoing a power that is a fraction, it's helpful for us to think of it as we are raising to the reciprocal. Okay, so raise to the reciprocal. That has nice alliteration to help you remember. Okay, and then we also want to remember that when you are applying the inverse operation, what you want to do first is isolate that radical expression. So if there's anything added or subtracted to the radical, we want to move that over. In some cases, you can only isolate one of the radicals because you have radicals on both sides. We'll talk about what to do in those type of cases. Okay, so it's either going to be a radical expression or an exponential expression. So in example 1, we're going to solve each equation, and then we're going to check for extraneous solutions. So earlier today I said, oh, we have to do that when the domain isn't 0. And we have to remember that one thing that we've talked about when the domain isn't 0 is when you have a negative under an even root. So you can't take the even root of a negative, okay, which means anytime you have an even root, that's when you're going to have to check. Okay, so we're going to do checks whenever we have even roots because you have restrictions to that domain. Okay, so we are going to start by isolating the radical expression. So we have to move over this 5, so we're going to subtract that from both sides. Okay, once you've done that, you are going to undo the radical by showing this step. Okay, so these are key steps that I'm going to be looking for on your reviews and on your quizzes. Okay, each problem has a rubric. That's part of your evidence of solving. And then your final answer is 120. Because it's an even root, we have to check it, and then we can write our solution. Okay, so when you are checking, you are going to plug in your x value as your first step. Okay, your first step should always look exactly like your given equation, but you have plugged in your value for x. Okay, now when you are checking, you can't move anything over, so I can't subtract the 5. You can only do that if you know that they're equal, and we're trying to prove that they're equal. Okay, so then we're just going to simplify here. This becomes the square root of 121. The square root of 121 is 11. When you add it, you get 16, so that is going to check. Okay, the check isn't something that has to take a long time. Your steps are going to go in order, and this is mental math that you guys can do very quickly. You just want to have your clear steps labeled there. And then if it does check, your answer is what you plugged in for X, not the 16. Okay, so your answer is X is 120. All right, so based on that, I want you guys to do the first step for B. So your first step is to isolate the radical. Okay, if you need to write out some long division, or you can do it mentally. Okay, so we divide both sides by 7. So you can write that out if you need to, or all you're asking yourself when you're dividing is how many times does 7 go into 8? 1 time. Okay, so 7 goes into 8 once with 1 left over. You just put the 1 in front of that second number now. So how many times does 7 go into 14? 2. Great. Okay, so then from there, we're going to raise each side to the power of 3. Okay, now something like this, if you have a double digit to a power that's bigger than 2, I would let you use your calculator for that, okay? If it's a double digit like that, if it's not something like 10. Okay, so 12 times 12 is 144. I guess you could do it by 10 and then by 2, but that seems like a lot. You have the 1735. Yeah, you should get 735. 728. Thanks. Okay, and then we're going to add 7. Oh, 1735. All right, and then we'll divide that out. Okay, so 5 goes into 17. How many times? 3. Goes into 23. 4 times. Goes into 35. 7 times. Okay, so for X, we got 347. Okay, so for this one, your cube, okay, your cube root is odd. So we said that you have to check if you have an even root. Okay, you don't need to do a check if you have an odd root. Okay, and the reason why is because if it's an odd root, your domain is all real numbers. You can take the odd root of a negative, so there's no restriction there. If there's no restrictions, you don't have to worry about extraneous solutions. Okay, you could plug it back in and check to make sure that you did your math right, but there's not going to be an extraneous solution with an odd root. All right, now for part C, you have a value in front of the radical, but the only way to move it over would be to divide, and then you would just have a fraction there. So you can't isolate both of the radicals, you can only isolate one, and it doesn't matter which side you put it on, Okay, we're just going to keep it there because it's a little bit less work. And then we're just going to raise each side to the power that will undo the radical. So if it's a square root, we're going to raise each side to the power of 2. And then you'll be left with the radicand here. On this side, you have to apply this to both. So it's like you're doing 3 squared, yes, and then the square root of x squared. Okay, you're not going to have to write out this step. Like when you're solving, you're going to be able to say, okay, 3 squared is 9, root x squared is x, and then from here you can just solve for x. So we're getting all the x's on one side. So we have 1x left over, x is equal to 6, and then we're going to check that because you have an even root. So again, anytime you're doing the check, your first step should look exactly like this. So it's 8 times 6 plus 6 equals 3 root 6. And we don't know if they're equal, we're trying to prove that. Okay, so then we're just going to multiply. So some of us are just going to have to focus on slowing down a little bit. That can be a challenge. Writing out our steps. And then when you get to root 54, let's just simplify that. What's the perfect square in the square root of 54? Translate. 9. Okay, so the square root of 9 is? Square root of 9 is 3, so that comes on the outside. 6 is left on the inside, so yeah. 3 root 6 is going to equal itself. So then this is going to be your solution. Okay, so based on what we did for C, can you guys do the first step for part B? So you guys gotta write your checks down with me. That's the important part of your process. Okay, that's something that you're gonna have to do on your quiz and on your review. Okay, so once you've decided that you're going to raise each side to the power of 3, remember, you're doing 2 to the third and root 3 times x minus 1 to the third, which is going to get you 8 times x minus 1. You have to make sure that in this case you distribute that 8. So if you guys can double check, we're not going to have 8x minus 1, you're going to have 8x minus 8. Okay, and on this side it's just the x plus 6, so we can drop that down. And then again, we're just getting all of our x's on one side, all the numbers on the other. Okay, and then this is another odd root, so you don't need to check. Okay, so if it's an odd root, you don't need to worry about doing your check for that. Okay, so let's start part B. Okay, so Z, what am I going to do to both sides for this? It's a cube root. It's okay. It's this. It's your cube root. No, ask questions. No, we're not talking like that. It's rude. Yes. Okay, so this one is a square root, so we are going to do the check for this. Okay, now I want you to think about this. When you have 5 minus x squared, you have 5 minus x times 5 minus x. So these are two binomials. So when we multiply those together, what strategy we're going to use? We're gonna FOIL, yeah. Okay, so go ahead and FOIL that. You want to organize it so it's standard form in the next step. You can do that as well. All right, and then Sarah, will you let me know what you got on this side whenever you're ready? Yep. You guys can keep going. You shouldn't be done, or if you're done, you can go to the next one. That'll be part of it. So when you do the 5 times 5, you get the 25. And then in the inside, negative x times 5 will be? Yep, minus 5x. And then on the outside, you'll have a negative 5x again. And then when you do the negative times the negative, the x squared will be what? Positive. Yep. Okay, and then, like I said, you guys can organize this so it's in your standard form here. And then if you have x's and x squareds on different sides, you want to move everything to one side so we can do what? Yep, we're going to set it equal to 0 and we're going to factor. Okay, so I'm going to give you another minute to factor, find those two answers, and then this is a square root, so we're going to check it. Okay, and then Maya, can you tell me what your triangle wheel was on this side? Yep, good. And then what did you factor it into? I whispered to her. Yeah, we factored it. What are we waiting for? Okay, so we're looking for what multiplies to -8 but adds to -7. So if it multiplies to a negative, you need to have one negative and one positive, okay? And then when we set those equal to 0, our two possible answers are x is 8 or x is -1. When you are doing your check, you're going to start with your x equals 8, and then if you have two of them that you're checking, just tell me which one you're checking. Okay, so if we're plugging in 8 first, what I want to see is this exact equation with the x plugged in. Okay, so that's always your first step. We don't know if these are equal, so we're just going to work on one side at a time. So we have negative 24 plus 33. So we have the square root of 9. Now when you take the square root of 9, your square root is already here. So when your square root's already there, the sign in front is the sign it has. So if it doesn't have any sign in front, the square root of 9 is 3. And we can see here 5 minus 8 is going to be negative 3. So these are not equal, and that means 8 is an extraneous solution. So we're just going to write it here that it's extraneous. Okay, and then we're going to check the negative 1. So if they're both extraneous, we're going to write no solution as our final answer. And if only one of them is extraneous, then that's going to be our final answer. Sure. Okay, so we're writing exactly what we're given here. The only difference is instead of the x, I'm replacing that with a negative 1. So then I have 3 plus 33 on this side, which is the square root of 36, which is 6. Okay, on the other side, if you have 5 minus a negative, you know that turns into a plus. Okay, so that does check. Just remember, your solution is what your x's equals, not what you checked here. Okay, so if you were doing one like this on a quiz, what you would write on the answer line is this, but you would have this as part of your work. Okay, and when you're looking at something like this, like keep in mind on a test, like your answer is only going to be worth 1 point, whereas all of this would be worth 4 points. Okay, so you got to make sure that you have your steps written out clearly there, okay? If they're both extraneous, then you just write no solution. Yeah, then you would write x equals 8 or x equals negative 1. And both of those can and will happen. All right, so go ahead and I want you to do F, and then I'll ask some of you guys to help me after I give you a chance to do that. If you finish F, you should be able to do G as well. Okay, and then go ahead and check your solution because it's an even root here. check our work for F. All right, so just like we did last time, we're going to have to FOIL there. So once we FOIL, okay, then we'll get x squared minus 8x plus 16. Once you have this side into a trinomial, we're going to move everything over to this side. And I like to do that so I can keep this positive. Okay, and then I don't like my 0 on this side because I have OCD tendencies and I like my 0 over here. It really does not matter what side you have it on. I also have to have an even number of emails in my inbox before I leave for the day because that's who I am as a person. I know. Right, so you can leave your 0 on this side is what I'm trying to tell you. Okay, you can do you. I'm going to do me. And I want to have a 0 on the other side. So then I get my -4 and my 3, and I'm ready to check those. And again, I'm checking this because it's an even root. Okay, so if I have x equals -4, what I'm looking for is that your first step has this exact equation, but it has your x value plugged in. Okay, that's what I'm looking for. Okay, and then from here, it's 36 plus 28. When you're adding those together, I like to add the 20 to the 36 first to get 56, and then I add 8 to that. And I know the square root of 64 is 8. Here I have 2 negatives, so it'll be a positive. That will be 8 as well, so that is going to check. All right, and then I'm also going to check for x equals 3. So again, my first step is just -9 times 3 plus 28 equals -3 plus 4. Okay, so when I do that out, I have -27 plus 28, which is the square root of 1. The square root of 1 is 1. So you do get 1 equals 1 here. Okay, so if they both check, your solution is going to be both of these. So your final solution will be x equals -4 or x equals 3. Okay, now, like what we talked about on the first page is if you have a power, you can just raise that to the reciprocal. Okay, 1/3 is the same thing as the cube root. Okay, so we do not have to check this one. It's an odd root. Okay, so we're just going to start by raising each side to the power of 3. Whatever you do to one side, you have to do to the other side. So if you raise this to the power of 3 to undo that power, the other side has to be a power as well. And we know that 3 cubed is 27. We're trying to get x by itself. I don't have to worry about a trinomial or factoring for this one. I'm just going to solve for x. And then I don't even have to worry about checking because it's a cube root. Okay, so based on that, I want you guys to do your first step for H. And then think about what your goal is once you've done that first step. Okay, so remember, one of the things I'm looking for is that you have your proper notation down. So if you have to the 1/2 power, each side should be to the power of 2. When you do 2x to the power of 2, you have to square the 2 and the x. So you should have 4x squared equals 4x plus 8. Okay, based on that, if I have an x squared and an x, the goal is to move everything to one side. I always move it to the side where my x squared is going to be positive to make it easier to factor. And speaking of making it easier to factor, if you look at the numbers in your trinomial, what's special about all of them? What's special about all the
Factor 4.
numbers in the trinomial? Yeah, 4 goes into all of them, right? So you can factor out of 4, or if you want, we have an equation. We can just divide both sides by 4. Okay, if you factor out the 4 first, you will have to divide in the next step. But when you have an equation, you can divide both sides by 4. Or you can factor it out and then divide. Okay, so that's going to give you x squared minus x minus 2 equals 0. So now we have a trinomial that's easier to factor because all the numbers in this are what? And you have prime numbers. They're only divisible by themselves or 1, or it is 1, right? Because the only thing that makes x squared is x and x. The only thing that makes negative 2 is a 2 and a 1, right? And then the 2 has to be negative so that the inside is a negative value. So x minus 2 is equal to 0. X is going to be 2. If x plus 1 equals 0, then x is negative 1. Okay, and then do we have to check this one? So this is 1/2. 1/2 is the same thing as what? Yeah, so this is the same thing as the square root. Okay, so yep, we're going to have to check it. Okay, so even root, you got to check. Okay, so for x equals 2, again, first step should look exactly like this. The only difference is you have 2 plugged in for x. Okay, so on this side it's just 4, that's great. 4 times 2 is 8. 8 plus 8 is 16. So we have 16 to the 1/2. Remember that this is the same thing as a square root. So if you take the square root of 16, what do you get? 4. So that's going to check. X equals 2 is one of your solutions. Okay, let's see if our other solution is going to check. Okay, so you have 2 times negative 1 equals 4 times negative 1 plus 8 to the 1/2. Okay, let's see if you guys can write out your proper steps for your check. I've written these notes out 3 times today, so you guys can write it out 1 time. Okay, so negative 4 plus 8 is 4. 4 to the 1/2 is the square root of 4, which is 2. Negative 2 does not equal 2. Okay, so that means this is extraneous. No, not for the even ones. Okay, for all of the even roots, you have to write those out. Okay. So the solution is x equals 2 only. Okay, and then if it's a odd root, then that's one you don't have to write a check down on the paper, but it is one where you could like plug it back in your head to check. Okay, but anytime there's an even root, I need to see a check with that. Okay, for part I, again, we have an even root, and there's 2 ways that you can do this. If there's a number in front that is multiplied, you can divide both sides by 3 to start. Or I know some of you have already tried this on your own. If you squared both of them to start, you could also do that, but you'd have to make sure you squared the 3. So it would be 9 times x plus 6 equals 81, and then you divide by the 9. Okay, so there is more than one way to do that. Okay, but if you divide first, then we would raise each side to the power of 2 here. We'd have x plus 6 is equal to 9. And then we just subtract 6 from both sides. Okay, and then we only have 1 to check here, so we have 3. 3 plus 6 to the 1/2 equals 9. Okay, so remember we can only work with one side at a time. When you are evaluating, you have to follow your order of operations. So before you multiply, you have to add what's inside the parentheses. Before you can multiply, you have to do the exponent. So 9 to the 1/2 is what? 3. So this is 3 times 3, which is going to be 9. So yay, this is our solution.
Square both sides, so
If you square both sides, you're solving. Yeah, so when you're solving, this looks like it is a solution. But if you plug that back in, you can see that you get -2 is equal to +2, because when you have the 1/2 power, this is going to hold the sign that's in front of it. So you can't have your negative of your square root there. Okay, so this one looks like an answer, but if you plug this back in, you're going to get -2, and that will not be equal to 2. So that's what you have to watch out for, is that you have it equal to a negative.